Hello, this is Mr. Huber. In this lesson, we're going to learn about some properties of logarithms. We're going to find they're very similar to the properties we should know and have learned about exponents. So there's a product, quotient, and power property, which we see listed here. And we want to go through each of these and make sure we understand what they mean, how we can use them. So the product property. Okay? The product property says if we take the log, whatever base, doesn't matter, b could be anything, of the product of two quantities, so m and n. They could be variables, algebraic expressions, numbers, okay? Whatever they are, if they're being multiplied together, then the log of their product is the same as the log of each of those factors separately. So if we had the log of 10 times 4, the log of 40, that'd be the same as the log of 10 plus the log of 4. When it's a quotient, we're going to subtract the two logarithms. So again, this should look familiar to what we see with exponents, right? When we're multiplying like bases, we add exponents. When we're dividing like bases, we subtract exponents. So for logarithms, when we're product, we add the two logarithms. When we have a quotient, we subtract the two logarithms separately. Important to note here that the m, whatever's in the numerator of your quotient, that's the logarithm that's first. Okay? And then the power property, okay? If we have log of m to the n power, that's the same as taking that n out in front of the log. So we can take the log of m, whatever that comes out to, and then multiply it by n. So let's see where we can use some of these properties in rewriting logarithms. So first we're going to expand these logarithms we see here. Okay? So the first one is log base 6 of 11 over 5. So if we look up here to our quotient property, right, this is going to be the log of m over n, 11 over 5. We take the log of m minus the log of n. So we could rewrite this as log base 6, we'd keep base the same, of 11 minus log base 6 of 5. And we kept the base the same. Note that up here. This base b is the same when we rewrite it. It doesn't matter what the base is, we just keep it the same when we expand. Again, this is expanding the logarithm. We're taking this logarithm and write down, expanding it in a longer form. Okay? So now we're going to see log base n of 5 to the 4th. How can we write that? Well, this is a power property. Right? We have 5 to the 4th, just like here we have m to the n. So how can we write that? Well, that's going to be 4 out in front of the logarithm. It's 4 multiplying the logarithm of base n of 5. Again, base stays the same. The exponent here, this exponent 4, moves out in front, multiplying the logarithm. Okay. Now here we're going to see expanding this. We have a couple things going on. We have a product. We have 3 times x to the 7th. And then we're going to have the x to the 7th. So we're going to write this out in 2 steps. First, I'm going to rewrite this using the product property. What happens here when I'm multiplying 3 times x? So up here, product property, we're going to add those. So the first step we could write is log 3, and I didn't write a base because it's a base 10. There's no base written, so it's assumed a base 10. We don't have to write a 10 there. Okay, plus log x to the 7th. Now we can expand this further because that x to the 7th we could rewrite. We have log of 3 plus 7 log of x. Then we use the power property to bring that 7 out in front of the logarithm. Again, the 7 is just a power of the x, so it doesn't go in front of log 3. It just goes in front of the log of x. So that's how we can expand logarithms. Now we're going to look at condensing them. So now we're going to have the longer form, and we're going to write it as just a single logarithm. Okay, so our first one is log 6 plus log 2. So we're adding here, that would be our product property. So this would be the same thing as having log of 6 times 2, which is the log of 12. In our next example, since we're subtracting, we can write that as a quotient. We have log base 5 of 40 over 8. It's important to know the 40 goes over the 8. The first logarithm's a numerator. In 40 over 8, we can simplify to log base 5 of 5. Do we know what that might be equal to? It's not base 10. We wouldn't be able to put it in the calculator. But one thing to keep in mind here is if we have the same base and argument, if these are the same, it'll always be equal to 1. So log base 10 of 10 is 1. Log base 5 of 5 would be equal to 1. And then our next one, we have a couple different things going on here. So first, we see the 3 here in front multiplying. We can write that as an exponent of the 2. So let's do that first. So I'm going to write this as log base 7 of 2 to the 3rd power plus log base 7 of x minus log base 7 of 15. And now this addition in the first 2 logarithms means we can multiply those. So this would be log base 7, 2 to the 3rd is 8 times x minus log base 7 of 15. Right, so I combined this right here. The addition of these logarithms means I can multiply 2 to the 3rd, which is 8 times x. 8 times x. Now I'm subtracting, so now I can write this as a quotient. Again, this would be kind of like we did up here. So we can write this as a quotient now. And so our final answer is going to be log base 7 of 8x over 15. We condense that down to a single logarithmic expression. So when we look at it, we can expand, we can condense. There's different times we might want to use those different properties. We'll see those going forward. For now, we just want to make sure we know how to rewrite them. Okay. Little break here. Live from Algebra 2. So you may be familiar with the show Saturday Night Live. Live from New York. It's Saturday night. So now live from Algebra 2. Who was the first host of Saturday Night Live? The first host of Saturday Night Live. There's a photo of him. I don't know if you will maybe even recognize him still. It's an older stand-up comedian. His name is George Carlin, and he hosted the first ever episode of Saturday Night Live. It was on October 11th, 1975. He hosted it one other time after that as well in 1984, but he hosted the very first episode of Saturday Night Live. Okay. So some of what we've done with expanding and condensing logarithms is nice, but it might not help us get a value because we know on our calculator we need a base 10, and we saw in some of those problems we had different bases, so it's not really going to work. Okay, if we look here at log base 4 of 7, how are we going to figure out what that's equal to? We can't put that in our calculator because when we push the log button on our calculator, it puts a base 10 here, not a base 4. So there's something we call the change of base formula. If we can change this base to a 10, we can use the calculator. So the change of base formula says if we have a logarithm, like we see here, this would be like log base 4 of 7. Okay, that's great. We can rewrite that as log b of a, so this a comes here, and we can make this base anything we want, as long as we make it the same in the numerator and denominator. And then we're going to take the logarithm of that argument, a, and then whatever the base of the original logarithm is, it goes in the denominator. So if we write this for our first example we had here, log base 4 of 7, okay, that'd be log 7 over log 4, okay? The 7 here is the log in the numerator, and the base of this original expression goes in the denominator. You'll notice I didn't write a base, right? This has to be the same base. Doesn't matter what I use. I could use base 5 for both of these. I could use base 18, okay, or I could use base 10. That's why I didn't write a base, because now I could put this in the calculator. I can use a base 10 for the numerator and the denominator, and I could get an actual value for this expression. So we can rewrite a logarithm with a new base, and if we use base 10, then that allows us to use the calculator to evaluate those, which is pretty useful. So let's see how we can do that and come up with some values. So this first one is that example that was on the last page. All right, and so again, if we write this as log base 7, or log of 7 over log of 4, and we use a base 10 for both those, we're going to put that in the calculator. When you put in log 7, make sure you put a parenthesis after the 7. Before then you do divided by log 4. Okay? And when you do that, you do log 7 divided by log 4, you should get an answer of, we'll just go to 2 decimal places for these. We'll do 1.40. Okay? It's about 1.40. So if you're not getting that, we're going to have to look at how are you putting in the calculator and what can we do to make sure you're entering it correctly. Okay? Again, check where you might have parentheses if you're using division correctly, things like that. Maybe put in log 7 and hit enter and then divide that answer by log 4. So work out ways where you can get that. If you're having trouble with it, make sure you're seeing me to understand how to enter these in the calculator properly. The next problem, again, you should be trying these next two on your own because you should have a good understanding here of how to rewrite these and then hopefully how to put them in your calculator. And if you've tried this, then we would know this is log 15 over log 2. Log 15 over log 2. Again, the 15 is the log we put in the numerator. The base of the original logarithm is what goes in the denominator. And so if you put this in your calculator, log 15 divided by log 2, you should get about 3.91. okay, about 3.91. And then in the last example here, we're going to have log 10 over log 8. We should have an idea of what log 10 is equal to. Log base 10, because we didn't write a base, we're using base of 10 is equal to 1. So this is the same thing as 1 over log 8. So if it's easier to just type in 1 divided by log 8 on your calculator, that's fine. So 1 divided by log of 8, and you should get an answer of about 1.11. Okay. If you type it in as log 10 divided by log 8, you should get that same answer if you're entering it correctly. Okay, so we want to make sure we know how to work with these logarithms, how to rewrite them by condensing and expanding using those properties, again, product, quotient, and power properties, and then using the change of base, which can help us actually evaluate logarithms because we can use a base 10 that allows us to use our calculator.